Thank you everyone for joining. Before I get started, as Andy said, my name's Adam Cornille, the Director of Advanced Analytics at Logic20. I've been living and working in the field of data science here in Seattle for the last 12 years. I originally studied graphic design and had a long, interesting journey from design to development to statistics. And I've had the pleasure of building a number of data science teams along the way. It's something I'm really passionate about, and so really excited to have the chance to talk about that here today. I've got with me Mick Wagner. Mick, do you want to introduce yourself?
Yeah, absolutely. And it looks like I may have missed the memo on the professional photo here. I went with a fun one from a trip back last year. But I am the Advanced Analytics Senior Solutions Architect at Logic20. I've been a lifelong analytics consultant, touching on kind of all flavors of analytics, from analysis to data science to data engineering and visual analytics. Across that journey, I've gotten Tableau and SQL Server certified over the years. And another certification that is a little bit more fun, I did pass my Cicerone prereqs a couple of years ago while I was working in Australia. Is kind of a fun way to pass time on my commute. And the photo I mentioned above, it's actually from a long hike we did in Peru. So it's kind of the Machu Picchu hike, but it was the alternative Salcante Trail, which covers a little bit further and higher distances and is a little more challenging and a little bit less crowded. But we'll dive into more later on today. I'll be leading the strategy breakout session, but I'll hand it off to Anne to give a quick introduction.
Hello, I'm one of the lead data scientists at Logic, and I've worked across a whole bunch of different software technologies, but what I'm probably most excited about is working across a lot of different industries, because that's given me a lot of perspective. Everything from HVAC to medical devices to so software, the software industry and web analytics. So I guess my fun fact is I play an 8-string jazz guitar, and I'm really excited to be here. Thanks.
All right. So I imagine, since you're all here, you probably don't think that it's a controversial statement that there is a lot of value in data science. I think the world has been demonstrating this very well for a number of years. There's been obviously a lot of hype around data science, but I think a lot of genuine value delivered. And by many accounts, we expect that trend to continue as the availability of data increases, as people's interactions have more digital touch points. There becomes more avenues to learn from that data, more avenues to act on it, and to make a difference across the business, no matter what business you're in. We've seen this in B2C, B2B, nonprofit, utilities, all across the board. There are ways that data science can make a huge difference for organizations. And tapping into that is really on the radar, I think, at this point, for anyone up to the C-level in any organization, where they're now evaluating how they get that value and use it to be more competitive in the market. So it's with that in mind that I think about how to develop data science teams. And I think that's really important to point out, because I try with my teams to build that alignment and vision, that they should really understand how big of a thing they are a part of, and the potential that they have to make a difference, especially when the techniques that they're practicing may be new in the market, whether it's a novel algorithm or a novel use case, or just new to the organization that you're in. So I think there's a whole ton of value to be tapped into here. But, it's not completely easy. And there are some important considerations to take into account. data science brings with it some baggage. There are um, obviously a lot of skills required in executing and building machine learning models, applying these statistical techniques. The technology around them is also, it's sometimes complicated. It's getting a lot better, but very quickly moving. As is the research on the theoretical side. The statistical techniques keep improving. We've seen, particularly in the last few years, in the realms of NLP and computer vision, great strides being made. Um, so there's that pressure of how do you wrangle all of that in order to successfully deliver. There's also a talent pressure. Uh, you know, the competition for talent may have improved over the last 10 years a bit, as more schools have started to offer data science programs, more people have gotten excited about entering the field. But to be honest, as someone hiring data scientists, it is still very challenging. And finding someone who is the right fit to deliver what's needed, has an understanding of the domain, has some practical um, pragmatism around how they deliver and develop, is still hard. Um, and so it's with these things in mind that I recommend a data science center of excellence. Um, Consider for a moment the alternative approach, which is that you start developing data science kind of off the side of the desk or as individual data scientists distributed around an organization. It becomes challenging to manage. And I put a picture of a fire truck here because I think a data science center of excellence makes sense in some of the same ways that I don't want to own a fire truck. There's a lot of infrastructure required in creating a fire department. Just having a fire extinguisher in my house is not enough. It makes sense for all of us to get together and pool those resources and have them in one place so that it's ready as we need it. And I think data science has a lot of the same scaling problem. That if you are going to build the infrastructure for deploying models, you'd like to build it once and get it right once, and have it available there, that rather than a proliferation of many different ways to deploy that all require overhead and operation. Um, so this is why in many cases, I think a data science center of excellence makes sense. But the way it makes sense and how you get there is an interesting thing. There's a pattern that I've witnessed a few times that I think is beneficial. There is a natural kind of, as data science use cases are published in the field, as people become aware of what is possible, individual teams may start picking at the edges, finding use cases for data science, finding a package or a piece of software that they can implement something with, and you get what I'm calling these pockets of data science. And this will often happen if you've got analytics teams separated throughout in an organization. This is great. It shows, they're able to prove value, spark the interest, start taking advantage of what's available off the shelf. But again, I think that as you scale, it makes sense to centralize these things, to have an economy of scale, to make the infrastructure more maintainable, to be able to serve use cases like real-time prediction. There's some genuine benefits of bringing together the data scientists. Not to mention from a talent perspective, having people together in a community where they can learn from each other and use the same sort of tool set so they can get up to speed very quickly. This is why I recommend centralizing. And I find that centralizing as a center of excellence, which is another way of saying sort of an internal consultancy, is a useful structure. You can pull together those individuals, get the economy of scale, building that infrastructure, and then start bringing them around the organization to identify and serve different use cases. What I also recommend when one's building this kind of a team is to not just drop in that centralized consulting, but draw from those pockets of data science. Find those people who are in those different departments who have piqued the interest and pull them in and train them up. This has some great benefits. In data science, statistics is just part of the problem. Understanding the domain that you're operating in is crucial. You really, in very few cases will you be successful just turning loose an algorithm on some data. You have to understand the data. And so if you've got the advantage of people who know the data intimately, that's going to make a big difference. It's also going to give you inroads when you are creating that centralized consulting to go back to the teams that they came from and already have an active relationship. One of the big reasons that data science projects fail is actually adoption. Building something that is designed for the workflow of the people it's meant to serve and then getting them to use it. That sounds so simple, but it's actually a very big problem. And so that's just some of the reasons why I recommend this structure. I also think that from a growth perspective, this gives you a place to focus. It gives you a place to put all of your data science talent in order to start growing a culture and best practices, and they can start to spread this back out into the business. So as you identify use cases as an internal consultancy, I advise, again, really thinking of it as a consultancy, spending time side by side with those end users to make sure that what you're developing is aligned with how they're going to use it. And naturally through time, identifying when it makes sense to start kind of budding out, helping them train up on data science, helping them build up some data science talent into their arms of the organization. But that centralized consulting group, that center of excellence, takes on a new role at that point. They're no longer the bottleneck for data science, they're now the leaders of data science. And they can start setting the best practices, setting the technologies, creating the internal trainings, and driving that thought leadership to push data science throughout the organization. Now, depending on the size of the organization you're in, maybe you don't reach that point. Maybe that's a scale, that kind of requires a certain critical mass. Maybe you just stay at centralized consulting. But this is the trajectory that I've seen for larger organizations, where ultimately you want to be able to apply data science, and you want it to be, something that's accessible to almost any group. And obviously another benefit of it then is if you've got a small group, say that you're, I don't know, just to pick on one, for example, your HR group is very small. You may not have analytic talent within that HR group. You may not be able to hire someone within that to act as a dedicated data scientist, but by having a centralized consultancy, you can still serve their use cases. There's one other side to this, which is a bit more strategic. When you have pockets of data science, it's often looked at as a cost. And I strongly recommend that as you centralize, you make it clear that data science is not a cost center. It's a revenue source. And whether that is new revenue or revenue saved through operations, it should be thought of that way, and it should be measured that way. I think this is really important for driving investment, and important on the flip side for the team in making sure, again, that they're, as I was mentioning in the beginning, crisply aligned to what they're delivering for the business. That you are setting goals as a data science group about how much revenue you want to influence, measuring that on a regular basis to report back to the business. So I mentioned all three of these words, I'm pretty sure, in the course of that. But to get through that journey, I really feel that you need these three elements. You need to establish a good culture and a good practice around acquiring people and growing them and maintaining the team. You need a strategic vision that is value aligned, that, again, the work that you're building as a data science team is aligned to, I guess it could be not just revenue. I shouldn't just put it in a box. Sometimes it's satisfaction. There are other measures for the business, but that it is measured in a value-based sense, and that you have the proper technology in place. And there's a lot in that box as well. You know, getting the deployment infrastructure right, getting the processes for development and deployment right. If you get all three of these elements together, you can start to create a highly functional team. And I've seen big impacts from that. But this is the lens that I look at it through. Again, we'll have breakouts on these, so I won't spend too much time on this now, but just to give an idea. And so if I take all of this together, what does it look like in practice? I've put together just a sample timeline of how I've seen this in practice. I was given the opportunity to establish a data science team for a company. And again, we were starting from a place that was similar to that pockets of data science concept. And so where I started was pulling together individuals from a couple of different departments and interviewing them each one by one, and really getting an understanding of where they were in their career trajectory, what they had built, what they wanted to build, and where their strengths and weaknesses were. I used this to create a map of the data science team and kind of laid together to get the right balance of skills and to establish a training curriculum. And by balance of skills, what I mean there is that you don't want to be too heavy on, say, just the computer science side of things. You need high quality code in production, but you also need people who understand statistics well. And when I was talking earlier about the challenges in data science hiring, this is part of it to me, that you've got many people who are coming to data science from academia who have an extremely strong statistical background, but are not used to value-based measurement or iterative development or computer science best practices, and may face some challenges in getting used to that kind of atmosphere. I've also had people who are coming to data science from the computer science side and have a real engineering mindset to it, but aren't able to innovate as much as those other individuals were able to. So this is kind of what I mean by having that right balance. And there's kind of a third piece to that, which is the domain expertise that we're talking about too. You really need elements of all of this. So long story short, I put together a plan for balancing out that team and started to develop with them an agile development process. And I recommend Agile for data science because there is such an explorative and iterative aspect to it. Data science is different than typical computer science and development projects in that you may not know from the onset if what you want to achieve is possible. In a typical programming exercise, I know I want to get from A to B, and I develop the solution. In data science, it just may be that the data that I'm providing cannot model what I want to predict. We want to find that out as quickly as possible. And so that's why I really recommend an agile methodology. There's extra benefits in that too, in the way that it makes the work visible, the way that it encourages collaboration and fits nicely into CI/CD pipeline methodologies. So I'm a big proponent of that. What I saw in executing that with the team was that getting the technology in place to support it, getting the agile process in place, and just getting everyone up to speed on that, reduced the delivery time by 5x. So just a huge difference in how long it took to go from I've got an idea to I've got a model in production. And part of that was bringing people into the mindset of minimum models in an agile sense. Go all the way through the stack. Access data, deploy a model, create a prediction. Maybe it's not perfect at first, you can iterate up, but it starts to prove the value right away. That mindset change was very powerful. At the same time, I started, as I recommended, using an internal consulting model to go visit other departments and do a mapping of the stakeholders and opportunities that I saw there. Sometimes these came from unexpected places. So one of the big wins that we found was working with the customer service group, and the stakeholder I had there was extremely non-technical and frankly suspicious of the ideas at first. But the way that we broke through that was to sit down with a customer service agent, spend some quality time side by side, understanding how they do their day-to-day, and then brainstorming what could be automated. And sometimes the solution is not data science. You've got to be open to that too. But in this particular case, we saw an opportunity to use data science to do away with some of the processing that they had to do, where we could maybe take some of the work off of their plate and just leave them the high complexity, high value items that require more white glove touch. We put together a proof of concept along those lines and brought that back to our stakeholder in the customer service department. I think what made the difference to her was seeing that if we took that kind of human moderated approach that I described, where we automate 75%, and then we leave the other 25% that's harder to do in human hands, we could get better than human quality in that 75% and still have a really great experience in that difficult 25%, maybe even better than before, because now the customer service agent has more time to focus. And all the while we saved quite a bit of money by doing it. And so that was an important lesson, I think, to the team about how to really stay closely aligned to what the customer needs, in this case an internal customer, and speak their language about the results. We didn't talk about p-values. We didn't talk about recall and precision or random forests or any of that stuff. We just stuck with how it was going to impact her and her team day to day. So that was just one sample of the work that we found in that time. By the end of 9 months, we had a pipeline of over $10 million worth of projects. We had just a couple of high value models deployed that were saving us over $2 million a year. And so already that team had paid for itself. And we were building up a reputation and starting to look at expanding the team and expanding the tool set. So it was a really exciting time. And I think just demonstrated the power of focusing on what works for the team, getting technology in place that facilitates them, and setting a strategy that's really aligned to the business.
All right. Oh, go
Not sure
please.
how I am on time.
You got 2 minutes.
Oh, perfect. So I think that's 2 minutes till Q&A time. And then I've also got a link here for feedback that you're welcome to use as well.
So there, I think people are looking to get into the breakout sessions to get the discussion going and get their questions answered. But I do have one question from the timeline or what have you. You mentioned at the top of your talk that adoption can be a problem in data science initiatives. And I'm curious if you tackle the problem of adoption in the strategy setting, in the tools, in the talent, or if it's a benefit that comes along with the structure that you've talked about.
problem from there. So, identifying where in your customer's workflow you can deploy data science and designing from that rather than from the ground up. But I think it touches on the technology because you need to ingrain in your team.
Hey, Adam, I don't know if it's only me. I'm not able to hear you very well.
Oh, I'm sorry. Is this any better?
Andy, can you talk? I don't know if it's just me.
No, I can't hear him either. So, and we have a comment in the chat. So I'm not sure what happened. Not sure what happened, Adam. What I was taking away from that though is it kind of cuts across everything, and there's bits in technology, there's bits in strategy, and what have you. So are you back, Adam?
So
I don't know, maybe.
Oh yeah.
Can
He
Oh,
is.
you are. Yes.
All right.
Cool. I don't know how much was audible, but I think of it as mostly strategy because you need to design from the customer's viewpoint first in order to gain adoption. And if they're part of the journey all the way along, of course, that helps. But I think it touches on talent because you need to ingrain in your team to think that way and ask those kinds of questions. And I guess be humble, think about what the end user needs rather than what would be really cool to deploy. I think that's a trap some data scientists do fall into. I would say third, it falls into technology. And I'll often put technology third, to be honest. Technology is part of the exciting parts of data science, but I feel like it should come last. It should be driven by what you need. I think it comes out here because if you don't have the deployment techniques to say, put in a live predictive model when you need one, you may not get the adoption you need.
Okay. All right. And Len would like to know if there's special skills that you need for leading a data science center of excellence.
Mm-hmm. This may be personal bias, but I really take pride in having done hands-on work and being able to jump in and write some code if I need to. Leading a very technical team, I feel like that is helpful for me at times in estimating their work, in being able to speak the jargon with them and understand when they're really blocked or what they're frustrated with. So I do recommend that.
Okay. And I think the flip side of that is who in the organization do you need to be your champion to get this up and going?
I think data scientists are not cheap. The technology is not cheap. There are ways to iterate up to this, but it does require investment. Again, I recommend treating it as a revenue source and measuring it and thinking of it that way. But to get the investment to start, you typically need good sponsorship. Data scientists are necessarily close to the data, and so organizationally, it often makes sense to place them in IT near your data team, whether that's a data warehouse team or some other engineering team.